Just two final questions. One, I want to give members of the panel, or if there's anyone in the audience that would like to share, the opportunity to share an example of a type of project that you're doing currently in your curriculum that involves IoT and AR. Obviously, a very short, concise summary of that type of project, just to give one another an idea of the types of things that are going on currently that you find effective. So we'll give the panelists an opportunity to share that. And again, if there's anyone in the audience that would like to share an example of an IoT AR project that you're doing currently with your students as part of your instruction, you're also welcome to do that.
When I was teaching, one thing that I learned was that if you build scaffolding, do you know what I mean by scaffolding? So educational scaffolding is that you can take an example and build out all the models, and then you can just focus on the parts that you want to teach to your students. They don't have to go through the process of building up all of the artifacts that are associated with it. So we built, my graduate students and I built out a experience where the students had to design an impeller. But we built all the models so that it was fairly easy for them to use the models to design the number of blades, the inlet, the exit, and then everything was automated through Creo to generate a wax. So a machining, they'd go on a 3-axis mill, and the mill would machine out a little wax version of it. And then they had to develop their own IoT strategy for how they were going to validate the model that they used to design with. And we had some very interesting strategies that came out of that the students would come up with, interesting sensors that they would use. We had one group, if you can believe it, who decided that the way they were going to do their flow, measure their flow, was they were going to attach a big garbage bag on the back of the impeller, and then they would just collect the all the air and measure. Anyway, so that worked really well. We had this set up, and it allowed the students to see the complete cycle from design all the way through validation, which was something that didn't happen very often.
Okay. So a good example, currently we are working on, it's a project, a group of students, about 20 students are working on the improvement of a manufacturing cell, a small one. It's about, I think, 3 meters long, and it's a transfer line with a robot, and it's a pickup process. And we asked them to analyze these classical systems, and to, after an overview of what is IoT and augmented reality, we asked them to think about improving this manufacturing cell with this technology. And in fact, the question is not on how to use the technology, but how to improve the manufacturing cell. Then we get back on this subject of business and what is the added value, finally, on existing system or existing product in integrating new technologies. And with this way, we review the work of our students each week, and it's very challenging for them to maximize their idea, and it's a project on a semester. Then let's see in next January what they have effectively done.
That's very interesting, actually. One example I can give, what we do, we started 1.5 years ago to build up a miniature digital factory where where our students build up small stations to have a production flow of a small product with 2 × 3 meters on a table. And the challenge now we're facing is bringing IoT to this factory to come up with a data model. Our students have to come up with a strategy, come up with sensor solutions, and also with a data model to achieve the following goal. We want to break down the classical automatic pyramid and change the way of production to an agent-based system, so that each station is offering a service, and all the stations are talking to each other and arranging the next production steps based on the information they're gathering from each other. And we're using small mobile robots to bring all the parts from the necessary station to the necessary station. And one goal we want to achieve there is lot size 1, where you can customize your product, and the whole production plant actually is rearranging its production steps following that customized order. That's where we want to go. It's going to be some way the road down there, but let's see what 2019 brings on that. And we're using ThingWorx and Studio for that.
I have some projects concerning a data analysis using deep neural network and industrial IoT containing machine diagnosis and mechanical engineering related something. And as an indication, we have some courses from member companies of the consortium containing PTC. And the Professor Fujino provides a very good course concerning IoT and Industry 4.0 and settings.
Perhaps one example which we tried or currently about to implement at this technical higher schools in Austria. So we have a few thousand students in these schools, and we are developing examples that can be used on all schools. So they have to design a small car, then print it out with a 3D printer, put a Raspberry Pi on it with a shield on it, and then control the engine. There's a small electric engine on it. And the goal is that we would define some challenges and competitions that can be played by students across Austria. So this example is not to have one very specialized thing on a university level. It should be an example which can be made by a few thousand students across Austria. So it must be very easy, it must be very simple, but it should show the most interesting and key concepts of IoT and new production technologies. So every school has a 3D printer, every school has a CAD system, everyone can afford a Raspberry Pi, everyone can afford a shield where you can collect all the sensor data. So this is a very simple setting, and the final goal is that we make some challenges, some competitions across all Austria.